So last time we are introducing some logical operators. I hope you still remember what is a proposition. So proposition is something, a statement that is either true or false, but not both. Okay, and then when we have a proposition, we can use some kind of variable like P, Q, R to represent it. So we may use P to represent the proposition 1 plus 1 is equal to 2. Or we may use Q to represent another proposition like 2 plus 2 is equal to 3. Okay, so each of these variables here that I'm writing, like P, Q, R, they are standing for propositions. Okay, now once we have some proposition, we can create new proposition by using logical operators. So this one is the negation, the not. So if we have a proposition P, then not P will be a different proposition, and then these two propositions always have opposite truth value. So when P is true, then not P is false. When P is false, then not P is true. So we have studied some example before. So for instance, let's say P is 1 plus 1 equal to 2. Let's say P is equal to this statement. Then not P, in English, you may say it is 1 plus 1 is not equal to 2. Is that okay? So although I may not be able to tell whether 1 plus 1 is equal to 2, but I can always tell that whenever this P is true, not P must be false. On the other hand, whenever P is false, then this not P must be true. Okay, so this is the meaning of creating new propositions using logical operators. So we have also talked about this AND operator, P and Q. It is true exactly when both of them, P and Q, are true. Otherwise it is false. Then we have also this OR. This is the OR. Or is the case where either one of these P or Q or both are true, then the P or Q will be true. Is that okay? And then there is something that is okay. So this AND or not, they are actually the most important logical operators. Later, throughout this course, we will see that no matter how difficult, so we can further do something like this. So for instance, we have P already, and then maybe we have N, we have Q. Then this becomes a new proposition, right? I'm creating a new proposition based on P and Q. So P and Q becomes a new proposition, and because it is a new proposition, I can further do something on it. For instance, maybe I can have OR, something like this, right? And now this is a new proposition, right? Then I can do something like maybe not of this one. So this is still a proposition. So I can do something very crazy. Maybe this is Q or not P, and then I have this one and this one, and maybe let's close it and this one. This is a very, very long proposition. We call it a compound proposition. It's not simple anymore. It has many things inside, but still it is a proposition, right? Okay, this proposition, the truth value of this proposition depends on what is the truth value of this P, Q, R, right? If we know P is true, Q is false, R is false, then there is a value for this one. Okay, so somehow you can think of this like when P, Q, R are known, then I know what is the truth value of this proposition. And this AND or not is so great that no matter how complicated your proposition is, maybe you can have a proposition that uses other logical operators like this. This is something, a new operator. This is the exclusive OR. Then we can always use another proposition without using the exclusive OR. We can always just use this AND or not to represent every possible cases. So that's why we call it, I call it importance. Okay. So later we can, today we will see that we can actually define many different kinds of logical operators. And then, yeah, we'll talk about this later, okay? Now, so we have also talked about this is exclusive OR. So usually we can write it as something like XOR. This is exclusive OR. So what does it mean? It means that when you have P and Q, then when exactly one of them is true, the result of P exclusive OR will be true. Otherwise, it is false. So this is a summary of what is happening. So if I have true, true, then the result will be false. But when I have true, false, or when I have false and true here, then the result will be true. And finally, if I have false, false, the result will be false. Okay, and I hope you still remember that at the end of the class, I'm asking you to show that no matter what P, Q, R is, then the result of this proposition, this is a very long proposition, right? So I have P exclusive of Q, do this first, and exclusive of R will always be the same as P exclusive of the result of Q exclusive of R. Okay, now how do we prove that? So how do we show that it is true? Okay, the trick is very simple. We try all the possible cases, and that's it. So what are the possible cases to consider in this particular example? So how many cases are there? First of all, how many cases? 8. Okay, so why is it 8? Because there are 2. Okay, this is about combinatorics, but yeah, let's try to reason it. Because we need to consider whether P is true or false. We need to consider whether Q is true or false. And we need to consider R is true or false. So there are, okay, this is combinatorics. You believe me if you don't know why is it true. Because all the choice of this one are independent. So there are 2 choices for P, 2 choices for Q. Altogether, that means that there are 4 choices for P and Q. And then together there are 2 more choices for R. There are 4 times 2 choices for all the PQR. Okay, so if we can consider these 8 cases, and for each of these 8 cases, the left-hand side agrees with the right-hand side in the resulting truth value, then we know that they are always be the same. So in that case, we are not worried about what? We are not worried about we don't know the fact that we don't know what PQR is, because for no matter what cases PQR is, this side must be the same or as this side. So you can always replace something like this by something like this, or vice versa. Okay. So how do we consider these 8 cases? Let's do this together. But okay, but let's do that in a. Yeah. Okay. Yes. In a nicely presented way. So I will talk about something called truth table. Truth table is nothing special. It is just a table that tells what happens if we choose different thing. So for instance, let's say, okay. So we will get back to this problem very soon, but let me introduce what is a truth table. So for instance, a truth table is something that summarizes the truth value of a particular proposition in different cases. So for instance, this is P and Q. Okay. So what we are going to do is we write down T, F, T, and then FF. Is that okay? So each line or each row represents a particular case. So this says that when P is true, Q is true. And then we hope that on this part, we write down what is the value of this P and Q. So when this is an AND operator, right? So true, true, we get true. Okay? And for AND, it is special. Only this case is true. All the other cases are false. Okay? And then we say that this is a truth table that summarizes what is going on about this P and Q. Okay, And then this is a very nice way, okay, to write things down. So now what we're going to do, so here it is more complicated. We have P, we have Q, and then we have R, right? And then how many cases are there? There are 8 cases. So what are these 8 cases? Maybe it is true, 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 false, true, false, true, true, false, false. Is that okay? And then we also have false, true, true, false, true, false. Yeah, not enough space. Okay, okay, 2 more lines. Okay, and then what should we do? We want to understand, or we want to prove that the left-hand side, the proposition on the left-hand side, is exactly the same as the proposition on the right-hand side. They agree in every cases. So we write down the left-hand side and the right-hand side. But it may be difficult to understand things quickly. So let's do this kind of intermediate things. So on the left-hand side, we know what is R because R is already there, but we don't know what is P exclusive of Q. So this is a term that we want to find out. And then in that case, so let me exclusive for R. Okay, so this table becomes very, very long now. And then we also have Q exclusive or R. And then we also have Q, we also have this one. This is the one P exclusive or Q exclusive or R. Okay, let's do that. Now we have what? We have, it remains to do what? To fill in the entries here. So here, what should I do? This row, the first row represents the case when P, Q, R are all true. So we know that these are true, so how about P exclusive of Q? What should it be? False, very good. Yeah, because here, so P, Q, R are fixed, you can say, on the left-hand side. And in that case, when P is true, Q is true, P exclusive of Q will be false. Is that okay? So here we can write down something like, this is false, this is true, this is true, this is false. So very good. Then true, and then true, right? And no, true, 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 true. Blah blah. Okay, so there are two more rows to code. And how about this one? How about this one? P exclusive for Q. You do this. Did I make a mistake? This one. Oh, thank you. And then the fourth one. Thank you. Thank you very much. Okay. Okay. False, false, true, true. Okay. Yeah, and here it should be something like true, true, false, false. Okay, something like this. Now, how about this one? So here we now know what is P exclusive of Q, which is false, and then we compare this with, combine this with R as well. So we will have what? So this is actually meaning false exclusive or true, right? So we can fill in here. So so this is true. Am I correct? Okay, and then the next one is false. The next one is false. The next one is true. True, false, false, true. And then the false, true. There are 2 more to go. It should look like false, true, true, false. Okay, should look like. Okay, and similarly we can do Q exclusive for R, and this time it is just based on Q and R. So here it will be false, true, true, false, and then what? And then again, very good. Yes, false, true, true, false. Is that okay? And finally, we have P exclusive of this Q or R. So P in the first case is they are all true. So it will be true, false, false, true, and then what? And then false, true, true, false, something like this. Is it okay? Okay, when everything is done, so at this moment we know all the possible scenario. And then we want to show what? We want to show that the left-hand side proposition agrees all the time with the right-hand side. So we focus on this one and this one, these two columns. Okay, you look at it, true, false, false, true, false, true, true, false. Okay, true, false, false, true, false, true, true, false. Okay, and that's great. Because whenever this is true, then this is true. Whenever this is false, this is false. Whenever this is false, this is false, and so on and so forth. Okay, even I don't know what is P, what is Q, what is R. But what I know is that no matter what P, Q, R looks like, then the value of this proposition will always be the same as the value of this proposition. So we call them equivalent. Okay, so they are the same. Is that okay? Good, very good. Now this exclusive OR operator is very, so truth table is very useful because it always can tell you for each of the possible cases what is going on for each kind of the proposition. But truth table has a problem. The problem is that here we have P and Q unknown. Okay, so there are 4 cases. Here we have P, Q, R unknown, and there are 8 cases. Now if what? If let's say we have 10 unknowns, then we will need to write down a truth table with nearly or more than 1,000 rows. And then in your exam, I guess you don't want to do that. Yes, because in the exam, it is often that we will ask you to prove some proposition is the same as the other one. So when the problem is very small, so when the number of variables like on the left hand side is 2 and here is 3, then it is okay to use the truth table. But when the number of variables gets larger and larger, we will need to look for other ways to simplify the proof. Okay, is that okay? Okay, so we will talk about more later, but at least at this moment the truth table works for us pretty nicely. Okay, now let's take a look of the exclusive OR thing. So if you look at it, whenever false, there is also another result that you can say. So apart from this one, you can also prove something like this: P exclusive for Q is equal to Q exclusive for P. Okay. Yeah. How do we prove that? You draw a truth table and they agree. Yeah. This is the simplest way. Okay. So with the first result, we will later see that no matter how long your proposition is, but if it is just consists of this exclusive OR like PQ, RS, something like this. Let's say I do this 2 first and then I do this 2 first. It is always okay to rearrange the ordering about which 2 should do first. So this is one way, this is another way. And the ordering of which 2 to be combined first doesn't matter, it turns out. So we'll prove that later when we learn induction technique. So, but what I want to say is that if this is like addition, you add 2 numbers. If you add 10 numbers together, you can add the one that is in the middle first and then add the one outside, right? But subtraction does not work. So subtraction, like 5 minus 4 minus 1, you need to do this from left to right. You cannot do 4 minus 1 first and then do 5 minus the result of that one. Okay, so exclusive OR is like addition. So the ordering of which pair of proposition to be applied first doesn't matter. So if this is the case, then we can normally write it down, because the bracket doesn't matter, we can just simply write it down as P, Q, R, S. Is it okay? Okay. Not just this exclusive or, and it's also the same, or is also the same. If you have a bunch of propositions and together, P and Q and R and S, you can do whichever first. Or it's also the same. If you have something like P or Q or R or S, so you can do P or Q first and then R or S first and then do the result together. Or you can do the middle first, Q or R together, and then P or Q or R, and then this one together with S or together. But a mixture of and or doesn't work. Okay, so we need to be careful. So there is a law here. We will talk about this. This is called associative law. So, but at this point, trust me. Okay. Now, if you have this understanding, then there is an easy way or quick way to evaluate a sequence of things all together. So for instance, I have true or false or false or true or false. What should it be?